Hi everyone here. I just wanted to show you the project I've been working on for the Chainlink hackathon. This project tokenizes the life cycle of a convertible bond from issuance to conversion to equity to coupon entitlement distribution using Chainlink CRE to automate the workflow. So quickly, what is a convertible bond? A bond is a financial instrument that represents a loan to a company. A convertible bond is then a bond that can then be converted to equity in that company after certain parameters have been applied and put in place. The real world problem here is that these life cycle steps can be tedious and are usually done across disconnected systems, smart contracts, backend APIs, compliance checks, traditional rails, coded operations, and so on. This creates a complexity that has built integrations and high operational overhead. My goal with this project is to show you that we can create a more structured and less complex system by using a single CRE architecture. Now, at the high level of this project, we have three components. First, an ERC-115 smart contract on Sepolia called Convertible Bond Token CRE. It manages bond tokens, equity tokens, and coupon entitlement tokens, and also exposes on reports so CRE can execute operations on chain. Second, an off-chain C# API. It stores bond instances, trades, and conversion requests, and handles the conversion from bonds to equities. It provides callback endpoints for CRE to execute these results. And finally, what puts these two together is Chainlink CRE workflow in TypeScript. This workflow has both HTTP triggers and an EBM lock trigger. The HTTP triggers handle issuance conversion, and coupon distribution requests. The lock trigger listens to a convertible bond created and syncs off-chain states automatically with on-chain data. Now, let's start with the first feature. So we're able to call the smart contract and it return back a transaction hash and some other event logs. We then run the CRE simulation and we use the EVM trigger, use the transaction hash that was sent from previous transaction, and we're able to call this API here, API bond convert to bond succeeded for bond ID 6. And now if you check this Swagger endpoint, this is Swagger instance here, you'll be able to see that our convertible bond C with smart contract bond ID 6 was created. So we are looking at the HTTP trigger for issuing a bond. So we receive a request from our off-chain C# API that calls CRE. CRE then uses an email capability and calls on reports that are used to call our function to then issue bonds. I can say this is now completed and work system result is success. So bonds have been issued. So what we are looking at, we're moving on right now to coupon and paying monthly coupons on the bonds. So with CRE, we can use HTTP triggers to trigger a coupon distribution request from the C# API, as you see in the log here, encode that report data, and then send it to the blockchain. And CRE completes the coupon distribution, and this is the transactional share from Sepolia, and you can see our workflow is a success. So this is the distribution of the coupon token that represents returns on the bond that we got. So we have come to the last and final part of the project where we are able to convert the bonds to equity. And this works similarly with the HTTP trigger. So the C# API sends a request to CRE to convert certain amount of bonds for a particular investor. It is encoded to report data and then sent to a smart contract function. When that is completed, there's a transaction hash done, and then CRE triggers the HTTP capability to call a callback function to let the off-chain system in C# know that this transaction is done. And that is how it works end to end. Check our off-chain system here. So if we query the DB here, we can see the bond conversion, and one of them we just ran now is completed today. Thank you.